Okay, so today we are going over 9.2, which is the quadratic formula, which I'm sure you've probably heard of in some form. But today we are going to see where that comes from. So that's exciting. These guided notes are currently sitting at the bottom of the 9.1 guided notes because I can't make a new Google Doc. Actually, let me test that right now. I'll see if I can do it. Oh, it works now. Okay, so I will fix that. So I can make a new Google Doc. So I will make sure that 9.2 is its own notes that's linked, blah, blah, blah. But anyway, so part 1, solving equations by using the quadratic formula. As we have just learned, any quadratic equation can be solved by completing the square. This means that if we were able to generalize the process of completing the square for a general quadratic equation, ax squared plus bx plus c equals 0, we could find a pattern for the solutions and ultimately find the quadratic formula. So what we are going to do is we are going to derive the quadratic formula from completing the square of a general quadratic function, right? So our most general quadratic function is ax squared plus bx plus c equals 0. And so what we're going to do is we are going to complete the square for that equation so that we can get a general quadratic equation that is just x equals, and we can plug and chug and, you know, honestly never have to worry about factoring again because the quadratic equation also always works. But I don't want to say that because I love factoring as much as you all hate it. Anyway, so we are starting with ax squared plus bx plus c equals 0. So ax squared plus bx plus c equals 0. And we know that when we complete the square, we need to get rid of the coefficient of x squared, which in this case is a. So we are going to start by dividing by a. And that will give us x squared plus b over a x plus c over a equals 0 divided by a is still going to be 0, thankfully. Okay. And now what we are going to do is we are going to do our actual step of completing the square, right? So we're going to have x squared plus b over a x plus something plus c over a minus something equals 0. Okay. And we know that that something that we need to add is going to be the coefficient of x, which is b over a over 2 squared. So again, this is our normal complete the square step, but now instead of dealing with a number divided by 2 squared, we're dealing with b over a over 2 quantity squared. So when we divide, so we can think about b over a over 2 over 1, use the c method. So that's going to be b over 2a. And then we're going to have b over 2a times b over 2a, which is going to be b times b over 2a times 2a, which is b squared over 2 times 2 is 4, a times a is a squared. So we're going to have b squared over 4a squared. And that is going to be what we are going to add. We're going to have plus b squared over 4a squared. And that is also what we are going to need to subtract, right? Because we can't really change the equation in any way. So what we add, we have to go ahead and subtract as well. Okay, so now what I'm going to do is I'm going to move this extra stuff to the other side so that I can focus on factoring that weird trinomial that I now have, which is x squared plus b over a x plus b squared over 4a squared. And I'm going to need to factor that. And that's going to be equal to negative c over a plus b squared over 4a squared, right? So I took what I had left outside of my parentheses and I moved that to the other side of the equation. Okay, and I'm going to do a quick aside for that right side of the equation right now because I am going to actually create a common denominator so I can add these together. So I have negative c over a plus b squared over 4a squared. My common denominator is going to be 4a squared. So I'm going to need to multiply negative c over a times 4a over 4a, because that's what is missing. So I'll get negative 4ac all over 4a squared. So now I have negative 4ac over 4a squared plus b squared over 4a squared. And that is going to go ahead and equal negative 4ac plus b squared over 4a squared. And that is what the right side of my equation is going to become. And I'm going to actually rewrite that so that I have positive first. So I'm going to have equals b squared minus 4ac all over 4a squared. And now the side that I'm going to focus on is factoring this x squared plus b over ax plus b squared over 4a squared trinomial, right? And so this is kind of gross and confusing, but if you think about it, we know that it's going to be a perfect square trinomial. So we are going to need to have x plus or minus, I guess, but since we have a plus and a plus, we know we're going to have x plus something, and then x plus that same something, right? So what times itself is going to equal b squared over 4a squared? And the answer is going to be b over 2a. So we're going to have x plus b over 2a quantity squared equals b squared minus 4ac all over 4a squared. Okay, so this to here we have factored. And now we are going to take the square root of each side to get rid of that x plus b over a quantity squared. So that's going to just give me, on the left side, x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac all over 4a squared. Okay, and I'm going to do another little aside here for that right side of my equation, because I can do a little simplification with my square root. So I have square root of b squared minus 4ac all over 4a squared. Hopefully you remember that we can break square roots on a quotient. So I'll have b squared minus 4ac all over square root of 4a squared. And then hopefully you can see that the square root of 4a squared is the square root of 4, which is 2, times the square root of a squared, which is a. So my denominator is going to simplify to just 2a. So I'm going to have b squared minus 4ac all over 2a. Okay, so that is going to be the right side of my equation currently. So now if I go back over here, we're almost done here. We have x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over, I don't know why I drew 2 instead of a c there, minus 4ac all over 2a, as we saw from our simplification of this square root guy right there. And then to solve for x, all we have to do is subtract b over 2a to the other side. So minus b over 2a minus b over 2a. So we get x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. But we have a common denominator here, so we can go ahead and just consolidate this into x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And that, my friends, is the quadratic equation that you've probably heard of and potentially used, right? So this equation is powerful because it tells us that given ax squared plus bx plus c equals 0, x will equal negative b plus or minus the square root of b squared minus 4ac all over 2a. And this, again, will work for any quadratic. So if you memorize this, it's kind of like goodbye factoring because you don't need to use it anymore. Although I still think that factoring is great and sometimes it works better because you can factor in your head quicker than you can do this whole quadratic stuff. But in case you were wondering where the quadratic equation came from, it is right here. It is because you complete the square of a general quadratic. So hopefully you were able to follow that a little bit. And now we're going to use this. So example, solve 3x squared plus 16x plus 5 for x. So we have 3x squared plus 16x plus 5. Sorry, I don't like how I wrote that, 16x. And we are going to want to solve that for 4x, okay? So we know that this is in standard form. So A is 3, B is 16, and C is 5. And then we just know that x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. So x is equal to negative 16 plus or minus the square root of 16 squared minus 4 times 3 times 5 all over 2 times 3. Let's see what 16 squared is. 256. So we're going to get x is equal to negative 16 plus or minus 256 minus 4 times 3 is 12 times 5 is 60 all over 6. 256 minus 60 is going to be negative 16 plus or minus the square root of 196 all over 6. Square root of 196 is, little known fact, 14. So we're going to get negative 16 plus or minus 14 over 6. Okay, so then you know that x is equal to negative 16 plus 14 over 6, which is equal to negative 2 over 6, which is negative 1/3. So there's one value for x. And then you also know x is equal to negative 16 minus 14 over 6, which is equal to negative 30 divided by 6 equals negative 5. So bada bing, bada boom, you have your two x values. So your solutions are negative 1/3 and negative 5. Easy as plugging and chugging. All right, let's go ahead and do one more. We have 2x squared minus 4x minus 3. So we're going to put it in standard form. So 2x squared minus 4x minus 3 equals, or just like we don't need equals anything. So we know from here that A is 2, B is negative 4, and C is negative 3. So x is equal to negative 4 plus or minus the square root of b squared, which is negative 4 squared, minus 4 times 2 times negative 3, all over 2 times 2. So negative 4 is going to be just 4 plus or minus the square root of 16 minus 24. Negative 4 times negative 2 is going to be negative 8 times negative 3 is going to be positive 24 over 2 times 2 is 4. 16 plus 24 is going to give us 40. So we're going to get 4 plus or minus the square root of 40 over 4. We unfortunately know that 40 does not have an even square root, but equals square root of 4 times 10 equals 2 square root of 10. So we can rewrite square root of 40 as 2 square root of 10. So we get 4 plus or minus 2 square root of 10 over 4. So then we know that x is equal to 4 plus or minus 2 square root of 10 over 4. But looking at this, we can see that 4, 4, and 2 are all divisible by 2. So we're going to divide out at 2 here. So 4 divided by 2 is 2, plus or minus 2 divided by 2 is 1. So we're just going to square root of 10 over 2. So we did a little bit of simplification there. And then we know x is just going to equal 2 plus square root of 10 over 2, and x equals 2 minus square root of 10 over 2. And those will be your two solutions, thanks to the quadratic equation. That's all I got for you guys today. Math Lab is posted, and let me know as usual if you have any questions. Thanks for watching, guys.